So for people who have just joined this call, this is a meeting of the export control work group, but we're actually using this meeting slot to do an export control webinar this time. We are doing this because during our discussions as a work group, again and again, we've touched on automation around export control. And one of our work group members, Julian, has not just knowledge of this space, but actually his company has a product directly relevant to it, the ability to look at export control matters in SCANOSS. So this webinar will be one of our technical webinars. And as with all our webinars, it's a place where you should feel free to interject with questions and comments. As with all our webinars, it is recorded, and the majority of the audience will be offline over time across different parts of the world catching up. If you are watching this recording and you have a question, don't worry, you can get answers even so. The best way to engage on export control around the OpenChain project is to join the export control mailing list, and you are always welcome to do so. But let's get to the topic at hand today. And before we formally start, I'm going to show the antitrust policy notice. We show this at the beginning of every meeting. The Linux Foundation antitrust policy can be found on our website in full. And if you're from a member company, you can ask questions of our counsel, Andy Updegrove. All right, SCANOSS and export control. I'm going to give a very, very brief introduction, and then I'll leave it to Julian to give you the specifics about everything. When it comes to what we're doing here today and what's happening, we're looking at how automation can help address things like export control. And Julian, who's CTO over at SCANOSS, has some really good information to share about the automation that his company offers. For those who aren't familiar, SCANOSS is a company that offers automation and tooling solutions for open source management. They're also a company which provides open source solutions for open source management. In other words, they occupy one of those unique spaces in the market where they have commercial services, but they also spend a lot of energy and time on building open source solutions for open source management. That's the type of organization we do like to see in the community, and we're very fortunate to have Julian here to represent it. Without further ado, then I shall hand over to our guest and let him speak for himself. Julian, the floor is yours.
Thank you. Thank you for the introduction. So let me share now my slides. You see it?
Yes, everything is perfect. Looking great.
All right. Well, thank you for the intro, Shane. It's been a pleasure to be part of this group. Yes, SCANOSS is a company that offers solutions in the open source management and export control. But I'm here to talk about not the company offering, but more the company contributions to the open source software and data community. I'm here today to talk about a contribution we have made for this cryptographic algorithm definitions as an open data set, which is part of our journey towards open data. So I'll be talking about this journey to open data. I'll be talking about the crypto algorithm definitions that I'm presenting here, and specifically for the export control use case, which is the main focus of this forum. And then at the end, I'll talk a little bit about who we are, for those who are not familiar with SCANOSS. So on our journey to open data, we started in 2021 by offering free access to our data set, free as in free beer, right? This is through a donation of a license of our knowledge base to the Software Transparency Foundation. That powers the OSSKB.org API, which allows anyone to identify open source down to snippet level, absolutely free and absolutely anonymous. So that was perhaps our first step towards open data. In 2022, we launched the Perl to CPE data set, and this is an open data set, which links in the package URLs with the CPEs. So it would allow anyone to find vulnerabilities in their open source components. And we did this as an open data. I mean, there are plenty of APIs out there that would allow you to find vulnerabilities, but we thought we'd just go one step further and contribute this as open data in our open data journey. And now we launched, and I'm announcing it here because it just happened a few days ago, this crypto algorithms open data set. The purpose of this is to define in a standard way how are we detecting cryptographic algorithms and which algorithms and which attributes we want to define for those algorithms. So moving along, building and maintaining a knowledge base, which is what we do for a living, is not easy. I mean, building a knowledge base of this size, this is a big knowledge base. When we're talking about the identification of all the metadata, including export control of all components, we have downloaded over 2 petabytes of data, 210 million URLs, 100 billion files, and over 3 trillion lines of code. And this is all available as free access through the OSSKB.org. You can imagine that it's a tremendous effort. And it's not just creating the knowledge base. There is another thing, which is maintaining it. Every second, there are a bunch of components added, a bunch of cryptographic algorithms found in new versions of software. So it takes a dedicated team of data scientists and engineers and a dedicated team of curators. This contribution of package URL to CPE links is maintained by a team of curators. That data set is available in GitHub in the URL that I showed before, and it takes the effort of 5 data curators that we have dedicated for that, and they are updating on a daily basis that data set. And then once you have the knowledge base and you have the means to keep that updated, then there is another expense, which is providing data access at a scale. That's also expensive. It takes a team of operations team dedicated to that, and then there is a high cost of hosting all this huge data set. So moving along, the cryptographic algorithm definitions, which is what we're here for. This is the GitHub URL. It's in the other slide. This is the name of the repo, and we decided to publish this under a CC0 license. I mean, this is the closest we can get to public domain. And the reason why we do that is we want this to actually be used. We don't want to have any limitations. We want to make it as easy as possible for companies to actually engage into this repo. And the idea with this is to have definitions on cryptographic algorithms where we define the name of the algorithms and some attributes and the rules to detect it, to detect each one of the algorithms. And then we have, of course, a directory with utilities. We have one sample script there in Python, which is a small script that would allow you to leverage these definitions to detect cryptographic algorithms in your code. So if you have this problem of needing to detect cryptographic algorithms in your code, here is a tool that is entirely open source software plus open data, and you can use it and consume it today. And then if we zoom into the definitions, basically we have a bunch of cryptographic algorithms, and this is YAML files. We thought it was the easiest way for people to engage into collaboration and adding keywords and modifying and contributing through the GitHub UI directly, because sometimes in this world of export control and trade compliance, not always you have developers or people who have Git skills, for example. And if we make a YAML file that someone can say, oh, you're not detecting this function name, then it will be very easy for someone to add it and contribute. So the idea here is to have first an algorithm list, which we have already contributed. Shane, if you remember, in the beginning of the export control group, we, this list of algorithms you see are in a repo. But now what we did is just we added the definitions. And these definitions have been open for quite some time because this is part of our mining technology, and Miner, which is the tool we use for mining open source repos, is open source, and it's been there for quite some time. It's just that it was difficult to use that Miner tool, which is a complex tool, just for the purpose of detecting cryptographic algorithms. And we also wanted to have the definitions out of that project so that it's easier for people to contribute. So that's actually what we did, and we convert them into YAML, and we did a number of improvements. What you're seeing here is old. It's like 2 or 3 days old, and things already changed because now we're looking at improving the naming convention to make it more compatible with SBOM formats. So, but basically, you define the algorithm name and then a strength, and then a number of keywords that are used to detect it. In the directory, I think I mentioned this already, in utilities is where you find the script to consume and then to consume these definitions and detect the algorithms in your code. So the idea with this is that people use it because it's already there, and it's already a solution which is entirely free and open to without any strings attached. And we want people to contribute. I mean, we believe that this is a good way to have people engaged. That it's difficult for a company when it comes to trade compliance. It's difficult for anyone to make a first step and say, this is the way we do things in this company, right? It's very difficult. But if we have an initial set of algorithms, and this would open up the debate and allow people to say, well, you are doing this wrong. Maybe you should do this other thing. And then people will engage and contribute. So the idea is to contribute new definitions for algorithms that were missing. It's an initial list. By no means that is complete. And then new attributes. Is there anything that we need to know about the algorithms that should be included? So then add the attributes. And then the idea, the ultimate idea, is to use it in an SBOM. I mean, if in an SBOM we are actually storing license data and vulnerability data, which is not fixed. That's a variable, and that changes a long time. Just like license data, cryptographic algorithms are fixed. So in a given version of a program, there is a fixed number of algorithms, and there is one license. And that is only going to change in future releases. So it makes a lot of sense to have this in your SBOM, because cryptographic composition is very important. I see something in the chat. This is Agustin. Okay, thanks, Agustin, providing the links. So moving on, it's not just about export control. I mean, this is, of course, the focus of this forum is to have consensus on ECCN classification, which is part of trade compliance. But there are 2 more use cases for knowing your cryptographic composition. Security compliance, the NIST has this crypto algorithm validation program. I mean, if you were to validate the algorithms, you need to know which algorithms you're using to start with. And then now there is this increasing concern towards the quantum safety of companies' products. Quantum computing will break cryptographic algorithms, and with that, products will become, affected. So you need to know your cryptographic composition, which is another use case. Now, in the world of export control, the idea here is to bridge this gap together between law and math. I mean, this is trade compliance, right? And trade compliance is legislation and rules written by lawyers. And for lawyers, math is something that is blurry, and there is not much definition on what they say. Well, they talk about strong encryption and weak encryption. There's not definitions on what does that exactly mean, or standard encryption or non-standard encryption. And then on the other side, you have mathematicians and cryptographers looking at the law and saying, you know, that's so blurry, because then they don't understand that. What does that actually mean? So there's a big gap between law and math. And the idea is to bridge this gap together. Every country has different legislation, and every company has their own interpretation for these legislations. So every company has a list of algorithms and the internal understanding and rules and classification of these algorithms. But you know, the idea is to actually find consensus. To find consensus on how to declare these open source algorithms, what is going to be the name of these algorithms. That would be perhaps the first step towards standardization. How do we detect them? How do we classify them? And which attributes we add to them? And then bringing these declarations into SBOMs is important. I mean, it will simplify distribution, consumption, and management. And if we did this with license compliance, and I say we as a community, and that, you know, this forum, the OpenChain, has a, you know, it takes all the credit there. I mean, this license compliance is standardized already. Why don't we do the same with export control? And that's the idea behind this forum. It will help reducing cost and risks, and of course improve transparency and efficiency. So the next step here is, well, first to get adoption, to enrich and maintain this data set and this tool, and define the ontology to declare these crypto algorithms in perhaps SPDX. It will make a lot of sense. And I close this part with a big question. Is OpenChain export control, this workgroup, interested in making this data set part of its commons? We are very interested, so that you know. I think it will make a lot of sense, but this is for the group to decide. Closing, just a little few words about SCANOSS. For those who don't know, we are a data company. Our IP is our knowledge base and this mining network that maintains this knowledge base. All the software we make is open source to facilitate access to that data. And this knowledge base is a knowledge base of published open source. There is no proprietary software there, and there is no unpublished open source. So as an open source company, yes? Sorry? Okay, I keep going. As an open source company, our repo in GitHub, you have the URL here where you can see all the open source, everything we make, the client software, our backend, the scanning technology, and the mining technology, everything is open source and is published in that GitHub repo. And we only use open source to make the knowledge base. So with our open source, you can create your own knowledge base. And there are companies doing this. Like, for example, one use case is companies who contribute software to the open source community and are not open source companies 100%. They are careful about not disclosing open source code that is not supposed to be released. I mean, IP leakage, that's a concern in companies contributing code to the community. So what they do is they build their own knowledge base with their own proprietary code, and then they scan the code that is to be released against that knowledge base to detect if there is any possible IP leak. It's just one use case. There are many other use cases, but the bottom line is that you can create your own knowledge base using our open source. As an open source company, we are an OpenChain partner, and we are present in the license compliance tooling workgroup and the export control workgroup as well, which is this forum. We are a member of the Eclipse Foundation and the Software Defined Vehicle project, and we are sponsors of the Software Heritage as well, which is a very important project. As an open source company on a journey to open data, a lot of an ecosystem built around our solution, and there are tools like Fossology or Fosslight or ORT that make use of our free data set and our open source software. And the same happens with commercial SCA vendors like TrustSource and others that I cannot mention, who also consume our data to either give snippet level visibility or improve visibility or decorate or aggregate their data with our data set. We also use SCANCode as our tool for detecting licenses. We're an open source company. We're not reinventing the wheel. We don't want to reinvent the wheel. SCANCode is a leading solution for detecting licenses. And also the Perl contribution is a great contribution to the community. We are using package URL as the main identifier for software components, and we're also adding software heritage IDs soon. There are auditing firms providing auditing services on top of our data set. And our technology has been proven in courts. I'm sure you're all familiar with the 2021 case led by Array in Italian courts using SCANOSS to gather the evidence. And there are universities hosting our free data set in their mirrors, and also research institutes contributing to learn more about the open source software through our data set. So that's all I had to say. Thank you for your attention. Is there any questions? We have plenty of time. Everything was either crystal clear or it was very confusing.
Can you hear me?
Yes, Elio.
Yeah, so yes, I have a hand up. And so, Julian, that's just, it's good thing. There's the idea is very good there. My question is, how you will plan to make this output of data in the way that we can like integrate with the other tools that do reporting other things? Because right now you can see that you have in mind this a set of, like say, a format that we can report this. But are you planning to do this format more generic or specific for the output of your tools?
Are you asking about the export control detection?
Yeah.
Yeah. Okay. For the time being, the contribution is the actual data set, the open data set of the open source, cryptographic algorithm definitions.
Yeah.
As far as consuming this data, well, we consume this data from Miner, our mining tool, to get the metadata from things we mine. But we also have contributed, it's a very simple Python script that is intended to be a CLI that would allow you to scan your directory and get your cryptographic algorithm detections. For now, I think it's a JSON array, what you get back in the console. But of course, the idea is to, in a separate, we're actually working on a Go CLI, a fully featured CLI that would allow you to consume this data in a more efficient way. And that's going to be a totally different repo, just to keep simple the definitions apart from the actual software. However, there is already a script in utilities that you can work, and it's very simple to change the format to anything you want from there. So yes, of course, we want to. In all the things we do, we use standard formats like SPDX in all these flavors and CycloneDX as well. So the intention is to have, since what we provide is data, is to make that data as compatible and easy to consume as possible. So Shane, you raise your hand.
Yeah, I've got two questions to help flesh out the conversation. First of all, it's amazing that this is being done. There's always been a real challenge in getting data. And as you mentioned, curating data is hard. And getting a community to curate data requires the type of dedication that's hard to apply when people have day jobs. But this leads to my first question, one of two. So you mentioned there's 5 data scientists at work on helping curate data. That's a lot of resources. So I guess the question that'll go out in the community, people will be like, why on earth is he giving away CC0 data when it's so expensive to collate? And I already know the answer is there's no catch. It's under CC0. But a lot of people will probably be trying to reconcile that versus business use cases they meet in the market space, and they'll say, why? So that's the question I want to bring to you for the audience. Why are you paying people to give something away for free?
Well, it just boils down to history. I've been in this industry for a long time, and so is everybody in the team, our CEO, our head of product. I mean, we come from my background, and it's always been painful for companies consuming software because all the solutions that are out there in the market as of commercial solutions to address this problem are proprietary software licenses. So, I mean, in our case, we know the DNA of open source, and we understand open source, and we are open source. That's the main thing. And second, we understand, and during my years at Ericsson, I remembered, because I'm old, you can see I'm just turning gray everywhere. And then in the old times, I remember preaching in the company, open source is a good thing. So you would just go out and saying, you should embrace open source. You needed to convince people to embrace open source. And that's not the case anymore. And at the time, the argument was, you can exploit a commercial proprietary license during a time window. At some point, if the need is global, there will be an open source solution, and your commercial proprietary offering will no longer be interesting. And we understand that very well. So it is by contributing open source and open data that you actually lead a technology. Otherwise, you need to catch up with whoever did it first. I mean, to me, it's a no-brainer, Shane. Unfortunately, our competitors don't really share that vision, but to us, it's crystal clear. So there is no question about us being open source. It's already there, and everything is open source software. And now we're on a path to open data. How do we make money? Well, we make money by providing companies with guaranteed throughput, guaranteed availability, on-premise deployments of the knowledge base when they need it, and so on. But I mean, our data, if we were capturing our data set and building it using proprietary tools, it will not be as interesting. So, Agustin, you're raising your hand.
Yes. First of all, I joined it. I'm helping SCANOSS since a month ago, and let me provide a complementary answer to that. If we think about those people working on curating data, if the data they are curating is standardized, it's simpler for them to do it, so they can invest the time in something else that is good for our customers. So standardization saves costs, and there is a lot of that in behind the company for doing this kind of thing. So we are small, growing but small, so we have to really put some thoughts on what we open, because data sets needs to be maintained, and that's something that we know well. It's expensive, as we mentioned, and so we were thinking, where is standardization good for everyone and good for us? And I think that this cryptographic algorithm is a clear no-brainer area. We mentioned three use cases, obviously three use cases that we are seeing in corporations. There are more. There will be more. So we want to get ready, and for that, standardizing the baseline, which is the data sets, and how we declare it is good for us too. I think it's good for everybody. Just like it happened with the licenses. Imagine curating licenses before everyone was, before XPDS and XBOMs were there. It was a pain. It was done through documents. It was done by lawyers. There was very little engineering there. And what we did there is something that we need to do in other areas, and this is one of them.
Absolutely. This is really a clear explanation, I think. And the next item for me is just to bring up our friends at Software Heritage. When Roberto and Stefano, we're setting up Software Heritage. It must be six years ago or something now, 7. It was clear that this might be a way not just to keep data, but to use data. Open source as a huge database, software as a huge database. And at the time, I mentioned to them, would we be able to use this for business process management? Do you think things like compliance and so on would aspects of the data needed to run automation be potentially usable? And that was a question because, as you well know, at that time, essentially, you had to build everything from scratch or choose a very expensive proprietary solution, and there were no kind of middle options here. So it seems that Software Heritage has not only found a way to thrive, but it's building relationships with organizations like SCANOSS, which is intriguing because that does seem to indicate that we're moving in the direction where certain amounts of data will be easily available globally. I mean, you've just said that you're looking for ways to host data and things like that, which for the audience listening in, this type of stuff is a sea change from where we were in the past. I just wanted to ask a question, which probably should go to Roberto really, but it's very expensive to host data. And Software Heritage has a problem that they've got support for hosting archives, but they mentioned things like, let's say, hosting a database that people will hit with CI/CD tools and providing, the APIs and the data access will be very, very difficult. Do you have any ideas about how hypothetically databases such as your own could be hosted in a way that would be economical and sustainable without, without one sponsor taking the full burden? And this goes beyond the scope of export control. It's really going to the general thing of it's amazing to have databases. If we're looking at this at scale, where do you think it could go for sustainability?
I think we share the pain with Roberto on the hosting costs and expenses and so on. Though it's a totally different use case and a totally different database. Roberto's database is a perpetual archive, and that is something that requires a crazy amount of storage. While in our case, what we have is metadata and indexed data for identification and declaration of open source components, which is fraction of, it's a totally different purpose. There are things that we could not answer, like, give me a copy of this open source component. We cannot do that. We don't have that. So storing data, however, although it requires a lot less data volume, the amount of our problem is the traffic. The amount of it, when you're scanning and detecting snippets, you're just hammering the API. So we have lots of companies and universities and end users and students hammering the osskb.org APIs. But this grows. This is a community and this is a foundation, and it just grows by adding more mirrors to it. So I see Elio and Nicola raising hands.
Yeah, let me go there. So just one other quick question about this ECC whole output. Did you ever try to talk with the guys from SPDX about what they are doing in their ECC profile? Because at some point they are creating a profile. I don't know if it's correct, right or not. They're missing things but since you are producing some similar data for these ones, it means that it ends up theirs in the end.
It will make a lot of sense, and that's an open question that I had in one of the slides, and there was an SPDX question mark. That's of course the intention is to make this in a way that is easy, and that's how Agustin recently suggested some changes in the naming conventions to have it a little bit closer to the SPDX naming convention. So that's absolutely the intention, Elio.
Yeah, I think Steve is in the main group, right?
Steve is not, no.
Yes, so that's you are in the SEC control group on the OpenChain, the SPDX right there.
Yeah, I'm in the OpenChain Export Control Working Group, but not the SPDX Operations Group, if that's what the one you're thinking of.
So now we have three sets of information that you need to go in together. See,
Yep.
Shane? Yeah.
Yeah,
So here is the data set. One thing is the data sets on its own, and the other thing is how you're gonna use it. And what we as a data company are worry about is the standardization of the data set for different use cases. So we can declare it in a way that it works for everyone. That will basically mean that you have some basic declaration and then you go to different places and try to adapt. We don't know how that is going to look like. So what we did was, okay, what do we have today? This is what we have today. And then let's try to shape it in a way that it's very basic, that you can have very basic tools so people can check. And little by little, yes, we're gonna get into an ontology that can be standardized. But as this group knows very well, that's a journey. And our part is help to standardize it and maintain the data. That's our part. And by bringing these to OpenChain, we know that there will be people that knows a lot, or to the Linux Foundation and OpenChain, that knows a lot about how to do this in a standard way that can lead to standardization. We are not those. We are the data guys here with initial information out of our services. So
Unfortunately,
I'm not
Augustine,
surprised, Elio. What I'm trying to say is that I'm not surprised that this happened.
Yeah.
It depends on who brings with the contribution, right?
Agustin, unfortunately to say to you, we are the guys, you, us, and everyone here. That's not other guys to do half of the job. Unfortunately, this it's how it goes from there. So the thing that is as the engineers part that what's data related, that you say, we should guarantee at least a minimum requirements of this data sets, that not everything, because otherwise if you try to say we did everything, it's a long fail and theirs, but and we need to care about how it outputs goes as well too.
Yeah,
Yes.
as I put in the chat, we are more interested in the standardization than in keeping the data set in a format that is close to us, because in the midterm, standardization is what it's also good for us. So
it doesn't make any sense for us to reinvent the wheel here. I mean, the whole point here is to standardize, right? Is to bridge that.
Julian, we are not inventing the wheel. We are inventing the wheel in this case because we don't have anything now.
That's right. And actually, there are 3 standards. I don't think that we overlap in any way with any of the things that are already defined. I mean, we're here trying to define how do we detect the algorithms. Has anyone done that? I don't think so, right? So we will, of course, adopt the naming convention and the identifiers for algorithms, and we want to do everything in a standardized way. So Nicola has been raising the hand for quite some time, and Steve as well. So
thank you for the presentation, Julian. I missed most of it, unfortunately. I did some technical issues, so hopefully I'll watch everything during the recording, and wasn't sure whether that was presented or not. But since Hilly also already asked the question regarding the export control schema and the business profile for the SPD by the SPDX work group, you mentioned that you aim to also implement this. But you mentioned the component indexing, and we are really currently trying to investigate a possibility to create our own internal database using like metadata and component indexing for our internal use. So with SCANOSS, is this available to actually do so? Or is it like it uses your own database for indexing?
with our open source software, you can create your own knowledge base. So yes,
okay, yeah,
there are, and I can tell you a use case. I cannot tell you who it is, but there is a company that is actually creating a small knowledge base with only a set of open source components that they want to detect and make sure, because of the license, that they are not present in their software.
So basically, it works like a vice versa. You can create your own, and then you can use your own to detect specific
Yes, yeah. So
specific components.
you can create your own proprietary for one use case, which is IP leakage detection. You can also create a subset. I'm only interested in detecting this set of components, and then you create your own knowledge base. Or you want to hit the big knowledge base with everything, in which case you either use our free API or you hire a supported instance from us.
Okay, great. That's really nice to hear.
Oh, thanks, Steve.
So yeah, that was my question.
Yeah, just to follow up what Julian says, since you can produce your own knowledge base, you can have your own knowledge base for your own proprietary internal stuff and rely on the SCANOSS knowledge base for all the open source stuff that you're consuming, so you don't have to scan all that stuff. They've already done it. So just pay them.
Exactly. So, I mean, for example, our commercial offering on export control is to provide you with the cryptographic algorithms we have detected in the whole knowledge base. So you give us an SBOM, we tell you all the cryptographic algorithms. You can also do it yourself by downloading. I mean, you can clone every repo and scan it using our open source and open data to detect it yourself, but that's work. So if you want to save that, then you can just use our solution and hire that service.
Indeed. Thank you for the presentation. Great stuff.
Thank you.
With regards to the detection you're doing at the moment, the utility that's online, that's keyword matching stuff. Were you also doing algorithmic matching as well? Analysis of actual computation, or is it all keyword based?
No, for the time being, it's just keyword detection.
Mm-hmm.
We are also looking at adding regular expressions as well.
Okay.
But for the time being, it's just a string search for function names.
Okay, so presumably one of the ways that contributions could be done is to expand the keyword list for different implementations of the same algorithms.
Absolutely, and new algorithms, because by no means that is a complete list. I mean, that's an initial list. It's what we have. And you see, now going back to the original question from Shane, why do you do this in an open way? Well, how do we benefit? Let's say that, Steve, the company you work for, and Nicola, the company you work for, I mean, start contributing their algorithms that they're interested in. Well, that's actually the tool we are using for mining so we are going to be getting a lot more richer information in our mining process. So that's the reason why, for us, standardization is a no-brainer.
Mm-hmm. To answer the question during the presentation, as a member of the working group, yes, I'm definitely interested in this all being part of the working group standards. That would be great. Are you also thinking about any representations of the country regulations, or are you focusing purely on the algorithmic stuff?
This is just pure detection of the algorithms. We don't want to get into the legal. I mean, we're not a legal company. We don't want to get into any legal assessment or statements at all. But again, for us, for someone to make that legal assessment, you need to start by knowing the cryptographic composition, right? Mm-hmm. That list is the input for your ECCN classification and other use cases, which we also have to keep in mind, because it doesn't. I mean, you need to know the software composition to answer other questions. So it doesn't make sense to do it in a different way for each use case, right? So we don't want to do it in a way that helps everybody in any other use case.
Let me put an example of the path that this can possibly take. I mean, just doing forward thinking. If you look at SPDX, they have this is OSI approved tag that, based on the license, you will get if the license is open source OSI approved or is in a gray area or not open source approved, and then you have the if FSFS approved, you have the tag. So basically, in your SBOM, you can actually do a lot of the license compliance engineering work. You can do it. Any engineer can check it out and on its own, right? So there are certain entities in European Union, in the US, in Japan. Now, and they all have their own recommendations, in some cases mandatory classifications of algorithms. Well, depends on the use case. You might want to have certain tags assigned to your definitions that in your SBON you will automatically detect if something needs to go to export control or not, or if something needs to go to compliance in your medical department, or if something needs to go to your security department, right? And just by simply having a good declaration done in a group by a group of people that actually know what they're doing. So you can actually get that far and start to see tools out there, internal tools that can at least highlight where does this software have to be curated internally in your organization.
Thank you.
Nicola?
Okay, thank you again.
I have
So
one. Oh, sorry, Nicola, you go ahead.
yeah, it will be quick. Sorry, Shane. Yeah, is there any way apart from like the cryptographic algorithm? Do you use any ECCN indexing, or basically the numbers for the different components that might be? Sorry, yeah. So yeah, that is a question that I have, because we are really also trying to not just map it by some indexes that you might use, but also by ECCN number, specifically for the export control.
Okay, well, the ECCN classification is something that comes after knowing your composition, and is something that will depend on a number of factors. I mean, we don't want to adventure. I mean, it is not our intention to make any kind of legal statement until we reach some consensus. I mean, imagine that in the future we all agree on a list of algorithms, on their attributes, and how does that affect the ECCN classification? Well, perhaps in the future we can hit the button and get an ECCN classification based on your location, because this will change from country to country, and based on the algorithms that you have in your software. But that would be the ultimate goal, right? For the export control.
I'm more or less asking not that you would actually give like a ECCN classification, but more or less if we have it, can we basically feed it back to SCANOSS? Or it is more or less what you've already described, that when you have your proprietary database and you've indexed different components, this is what you basically use to do a custom scan, so to speak, and not the classification itself.
No, the intention is to actually add attributes to the algorithms. So if we have all the attributes that are required to make a classification, then we could adventure at the end a classification. And it would be beautiful if the industry can agree on a way to proceed and a common understanding, bridging this law to math gap, right? That is the ultimate goal, Nicola.
Yeah, great. That's really a nice way how things are developing. So kudos.
Yeah, I'm not sure that you could do that, because I think it's a bit like, as an analogy, functional safety. You can do an analysis of software and provide an assessment of a piece of software as a safety element out of context, but you can't make an assessment of the final product and its context. In the same way that you can make an assessment of what a given open source component or library contains, but you can't say for a final product where it's coming from, where it's going to, and wonder what conditions it's being used in the marketplace.
That's right.
And individual companies should decide.
When it comes to custom city, what matters is what you're actually letting out of the country, and you're not having that visibility at the time of scanning. Yeah. Jan?
Yeah, hi. We have faced the same problem actually, and then we decided in discussions with our customers that best what we could do is to give them an information about a certain estimate of criticality. And then it's up to them to make the decision to say, okay, in this product, we are more closer to sort of military usage or whatever kind of thing. Or this is more kind of desktop tooling, that is used by someone, and then it's less critical circumstances, and therefore we decide then this is more or less acceptable. So that even within the company, the understanding of what is an acceptable use or relevant for declarations is totally different, not only from the country where you are in, but also depending on the country where you're delivering to. And because sometimes it's not export controls, but import restrictions. Yeah. So, for example, in France, I think you need to have declared everything that is capable of encryption, or encrypting things. And it's so, from my point of view, it's so difficult to really give a range and a classification. And when we were starting this project and we had this crypto law thing, we were asking the international consortium on blah, 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 how they call it. They are actually defining these sort of ECCN standards. And they were not willing to enter into this topic. Yeah? So that's really strange. I mean, how could we then go there? That's something that I cannot yet understand or have a meaning on. Yeah.
Agustin?
So a few years back, well, quite a few years back, when I was managing projects with operating systems, the entire license compliance topic was in the hands of basically the lawyers of the company, some maybe compliance manager. So the question back then is, this is open source. There should be a way in which part of that work can be done from engineering, at least part of the work. And then when you try to think, so we do not have to wait until the end in order to understand what do we have to, if it was good enough for the company or not, and we have to go back, take away software and change things, putting at risks all the deadlines, all the even the profits, right? So when I first reach out to this topic, I was like, it seems that from certain point of views, it's a similar problem. We don't know where the solution is going to take us, how much we can upload. I remember in that license in compliance times that people were saying, well, we will never be able to anticipate the dependencies of the licenses, because that depends on how you construct the software and how you use it. And that was correct, and it remains correct today. But the truth is that we are seeing, everybody's seeing now that we can upload a significant part of the work into engineering. We have even created a new role, which is the license compliance engineer that uploads a whole bunch of work. We are seeing this process of automating it. So you can, with open source, you can actually stop putting at risk your deadlines and your profit at the very end. My question is, can we do something similar with these topics related with export control? And what we've learned with license compliance is that declaring is sometimes the first step. Then build tooling around that declaration, and then you take it from there. And probably because the regulations are stronger, because each country is completely, in some cases, very different, we might not get that far. But I think there is a lot we can do about it.
Certainly. I mean, one thing, and although, Steve, you cannot anticipate what would be the actual complete software composition at the time of exporting, you could be interested in knowing the ECCN classification of every open source component, for example, right? Because, I mean, an open source component is fixed. This is what there is to it. And then maybe starting to implement policy management, just like we have policy management based on software licensing. Maybe we can have policy management based on, I mean, if you are going to be making something that is going to be exported to every country, then you might want to avoid strong encryption if it is not necessary for your application, for example. So this could be very useful as well. But for that, we need to get to the ultimate goal, which is to build this bridge and have some common understanding and consensus on how to classify cryptographic algorithms.
So I have one item to end. You mentioned that you'd like to have the data hosted somewhere like, for instance, OpenChain. Now I'll of course bring this up. We have a board meeting on March 26th, so I'll bring up at the board meeting. This is one of the items, and I'll have to give you feedback on that. It depends on where the companies fall. For example, we don't host software because there was a feeling by some of our board members that it was important for a standards project not to host anything that could be an implementation of the project's proposed methods. But anyway, I'll dig into this. Now, hypothetically, if OpenChain can or cannot host this, the basic principle at play seems to be that you're looking for an independent, neutral host of this data, someone who can help be a space for it. And I think what I can commit to doing is bringing up with my board if they're willing to do it, and if not, helping anyway to find you another home for this data that's part of either Linux Foundation or somewhere else that would host the data. And this is a remarkable opportunity to have on the table. And the question I had was just, do you have any timescales for when you want that done? How should I push this? What's my win?
Shane, you just say something. You say that they're reluctant to host software, and what we are looking is at hosting our data, right? So that's maybe that's. I mean, here we're talking about not the software implementation or anything, just the definitions of cryptographic algorithms. This is pure data. So that might be an argument for you to bring in that discussion. But if it isn't the OpenChain itself, yeah, well, any neutral territory will be very welcome.
No, absolutely. Well, you have my commitment to help work on this with you, and I'll bring it up with my board, see where they're at, and I'll also be helping you do this anyway. So assuming then that our time scale is when we can get it done, that's great. That's an action item. I'll be coming back to you after March 26th with feedback.
Absolutely.
Yeah.
For the time being, the you know where it is, you know where to find the repo, and we'll continue to work there. So if anyone, we welcome any contributions in its current location, and hopefully we'll find a place to host it. By the way, Shane, the fact that this is CC0 might also be another argument to your favor, right?
It's a very strong argument in favor, because it also means that it's pretty clear that this data is designed for people to take. It's designed to use. So I'm going to be bringing this to the table with a positive view from my side. I always think that data is great. CC0 data is even more wonderful. And we're at a time where there's a market gap. People want help here. So we're going to work out a way to make this even more available. But what you've already done changes things. I mean, this is already a phenomenal resource that alters what we can do in this space. So, huge kudos, Julian, to you and the team.
Thank you.
And
Thank you.
well, I've got to say thank you, and thank you for coming to explain it. And you can tell the interest by the fact we've spent over 30 minutes with just the Q&A.
Well, thank you very much for the space, everyone. Thank you for the time, and thank you for your attention.
Have a beautiful day. And everyone who came on, thank you for being here.
Thank you.
Thank you. Goodbye.
Thanks, Augustine. Thanks, Stephen. Thanks, Helio, in absence. Bye-bye all.